All right, welcome back to, we're at 6.3 part 2 of proving identities. And now we're going to be proving identities that involve the double angle identities. So right away for question number 1, you'll notice the cos 2x and the sine 2x. So again, I'm just going to whip over to our formula sheet. On the formula sheet, we're talking about these ones right down here. So usually the first step in these questions is to convert from either sine 2 alpha in this case, or cos 2 alpha, or tan 2 alpha. You'll notice that sine, the double identity for sine, only has one solution in our formula sheet, but for cos there's 3 different solutions. So when you're doing cos, the double identity for cos, it is possible, regardless of which one you choose, to get, to solve. But usually there's one that works better than the others. So let's take a look at this first one. I've already gone ahead and written the first step into the left-hand side and equals the right-hand side. And it's the right-hand side that we're going to have to substitute the double identities. And I also did a little cut and paste. So I'm thinking, okay, for sure the denominator is going to turn into that version there. So I'm going to write 2. And in this case, it's x that we're using, 2 times sine x times cos x. And now the numerator, we've got a few choices. So I'm going to say 1 minus, and then we got to pick one of these. And this, I'm just thinking, I got sine x and I got cos x. I think I kind of like this one because I'm going to get the 1 minus the 1, and then that will disappear. So let's try it out. So if I write that part in, I get 1 minus 2 sine squared x. I can put this parentheses a little closer. At this point, when I drop those parentheses, I'm going to get 1 minus 1, but then I'm going to be subtracting that negative. So what I end up getting in the numerator, the ones cancel each other out. I'm going to get a positive 2 sine squared x all over 2 times the sine of x times the cos of x. And now everything falls into place. So the 2's are going to cancel each other out, and one of the sines are going to cancel each other out. So I end up getting the sine of x divided by the cos of x. And looking back to the left-hand side, ooh, that's so easy. That is the same thing as the tan of x. So I can say that these two sides are now equal. Awesome. Okay. Let's go ahead to the second one. First, I'll just copy this out. Okay, so I've copied that out. I also brought that section of I did a cut and paste again from the formula sheet. So I've got a choice again which of the cos double identities to do. And let me see, this one has a cos and a sine in it. This one has 1 minus sine, and this one has a 2 cos squared. I'm thinking I like this one here the best because now in my numerator I'm going to have everything will be in terms of cos, and then I think I might be able to factor it. Let's see how it goes. So the first thing I'm going to do is I'm going to substitute this for this over here, making sure that I write theta instead of alpha, of course. So I will get 2 cos squared theta minus 1, and then I'll get minus cos theta all over. Now the sine, I don't have a choice. I'll do 2 sine theta times cos theta plus sine theta. All right, so looking at the numerator, I think the first thing I'm going to do is I'm going to reorder this so it looks more like a regular quadratic. So I'm going to write 2 cos squared theta minus cos theta minus 1 all over. And I can do some factoring on the denominator. Both terms have a sine theta in common, so I'm going to factor out that sine theta. I'll get 2 cos theta plus 1. And now sometimes it helps to sort of on the side here, I'm going to think this is like 2a squared minus a minus 1. So this is kind of off the side of my rough paper here. I'm sort of thinking, all right, so I need 2 numbers that multiply out to -2 and add up to -1. So I think that -2 and +1 will work. So that's what this is going to turn into. So I'm going to get 2a squared minus 2a plus a minus 1. And then out of the first two terms, I'm going to factor out a 2a. So I'll get 2a, a minus 1, plus 1 times a minus 1. So I'll get 2a plus 1 multiplied by a minus 1. Let's just multiply those out and let's FOIL it out just to see if it works. So 2a times a gives me 2a squared. And then I've got 2a times minus 2 gives me minus 2a, but then plus 1a here. So that gives me the minus a, and then I do get the minus 1. Okay, so if I'm going to make use of that, over here I'm going to show my results of factoring, but instead of using a, of course I've used cos theta. So I'm going to get 2 cos theta plus 1 times cos theta minus 1 all over sine theta times 2 cos theta plus 1. So now I have this common term of 2 cos theta plus 1. I can cancel off the top and the bottom. So now I've got cos theta minus 1 all over sine theta. This is a good time to go check out what I have over here. I've got cotan minus cosecant. So on the right hand side, this boils down to cos theta minus 1 all over sine theta. Let's work with the left hand side a bit. Okay, let's take cotan and change that into cos theta all over sine theta minus cosecant is the reciprocal of sine. Now this is quite convenient because I have two fractions with the same denominator, so I can say this is going to have a common denominator of sine theta, and it will be cos theta minus 1. Now when I compare, that is actually, we're done. No more work to do. Okay. A little bit of factoring work there. My advice too is like, yeah, when you're done this, just multiply it out using FOIL and just do a check to make sure that that is equal to that, because it's remarkable how easy it is to make a little mistake factoring. All right, let's take a look at number 3 here. We've got the 1 minus tan squared and 1 plus tan squared. So it seems to me that we're going to have to take a look at that. So I'm going to take a moment to copy this out. Okay, so I already went ahead and took those tan squared thetas and rewrote it as sine squared theta over cos squared theta. And I'm just leaving my cos 2 theta for now, because remember, that's the one where I have 3 options to choose from. I'm going to work with the left hand side and then see at the end which one it looks most similar to see how it works. Okay, so on the left hand side, that's kind of complicated. I've got, in the numerator, I've got a whole number and a fraction, and in the denominator, I've got a whole number and a fraction. So just as a reminder, in order to combine that 1 minus sine squared theta over cos squared theta, I need to have the same denominator. So here's what I'm going to do. I'm going to multiply this 1 here times cos squared theta over cos squared theta. So that here I'm going to get cos squared theta minus sine squared theta in the numerator, and then cos squared theta in the denominator. So that's in my complex fraction. I'll just do that part first. So over here I'm going to get cos squared theta minus sine squared theta all over cos squared theta. So that's just from that numerator. Now looking in the denominator, same idea. I'm going to multiply that 1 times another version of 1 of cos squared theta over cos squared theta. And so now I'm going to get in the denominator of that complex fraction cos squared theta plus sine squared theta all over cos squared theta. Okay, so now when I've got this complex fraction, when I multiply by the reciprocal, I'm going to see those cos squared thetas cancel each other out. I'm going to go ahead and like rewrite it all out, so I'll just do this quickly. Okay, so now that second fraction, I'm multiplying by the reciprocal, and then you can see that this cosquared theta and that cosquared theta are going to cancel each other out. To be honest, you wouldn't even have to write this entire line out necessarily. You could think of this, another way to think of it is I could multiply this by cosquared theta all over cosquared theta, which is a version of multiplying by 1, and then you would be canceling those out as well. But I think this is the method that most of you will be familiar with. So let's keep it familiar. So now I've got cosquared, oh, I forgot a theta. Half mark off. Okay, cosquared theta minus sine squared theta all over cosquared theta plus sine squared theta. I'm hoping that some of you look at this and see this. Right? Sine squared theta plus cos squared theta equals 1. So let's go back. That's the same thing as 1. So really my next step is to say this is just cos squared theta minus sine squared theta. I'll put an over 1 just to make it very clear that I substituted. I'll cancel this and this out. And then it'll be very clear that I recognize that cos squared theta plus sine squared theta is equal to 1. All right, so now it's time to go and say, oh, what version of cos 2 theta shall I use? So going back to my formula sheet, of those 3 versions, well, look, I've got one all ready for me, right? This one right here. So it's actually exactly the same thing. So I'll just go here and I'll say that is equal to, cos of 2 theta, and then left hand side is equal to the right hand side. Nice. Is that, oh, that's it. Okay. So, oh, somehow I lost my page. I'll get back to the bottom here again. We've done a lot of identities. Okay, so these are questions from the textbook to practice. I was looking at these, and I think I'm going to say don't worry about number 12. Otherwise, they look pretty good. Try those out for practice. And again, another method you could do is just go over these questions that I did, cover them up, and try them again. All right, I hope that works for you, and I'll see you in class.